So we have a quadratic function f of x is equals x squared minus 2x plus 3. And we need to find the following information about this function. First of all, we need to write it down in standard form. Then we need to find its vertex and x and y intercepts. We also need to graph it, and we have to find the domain and the range of this function. So let's start by doing part A. The standard form of quadratic function is a times x squared plus bx plus c. So the standard form of our function is f of x equals x squared plus negative 2 times x plus 3. Okay, now we can move on to part B. This is standard form. So, for part B, we need to find the vertex. To do so, let's start by finding x coordinate of the vertex, so xv. We can find it by using the formula negative b over 2a. So b is a coefficient in front of x, which is negative 2. A is coefficient in front of x squared, which is 1. So 2 times 1 is just 2. Well, this will be equal to 1. So now to find y coordinate of our vertex, we just need to find f of 1. So we will substitute 1 for x in our function. We get 1 squared plus negative 2 times 1 plus 3. And this equals 2. So the vertex is 1, 2. Well, now let's look at x-intercept and y-intercept. Let's start by finding x-intercept. So to find x-intercept, we need to let y be 0. So y is 0. That means that x squared minus 2x plus 3 equals 0. Now let's try to find the discriminant. So the discriminant is equals b squared, so minus 2 squared minus 4 times a is 1 here, so it's 1, and times c, so times 3. Negative 2 squared is 4. 4 times 3 is 12, so it's 4 minus 12, which is negative 8. And we get that our discriminant is negative, it's less than 0, and that means that x-intercepts do not exist. So no x-intercept. Now let's look at y-intercepts. So to find those, we need to let x be equal 0. So x equals 0, and now we just substitute 0 for x in our function. So f of x, f of 0 equals 0 squared minus 2 times 0 plus 3. So we get that f of 0 equals 3. So that means that y-intercept is happening at the point with coordinates 0 and 3. Great, now we move on to part C. We need to graph it. To build the graph for this function, first of all, let's draw the vertex on x and y plane. So we know that the vertex is 1, 2. Then this is 1, this is 1. X equals 1, y equals 2, so it will be here, 1, 2. Next, we can draw the y-intercept. So y-intercept is 0, 3. So x is 0, y is 3, then this point is right here, 0, 3. And then, since we have a quadratic function, its graph is a parabola. To build a parabola, we need at least 3 points. So we need to find one more point. To do that, we can just substitute any value for x and find y. So for example, let's substitute 2 for x in our function. So let's find f of 2. It's equal to 2 squared minus 2 times 2 plus 3. So 2 squared is 4. 4 minus 4 plus 3 is 3. So we get another point, which is 2, 3. Let's find this point on our xy plane. It's right here, 2, 3. So we have 2 points and 3 points, and 3 points defines a parabola. So we can build our parabola now by just connecting these points very smoothly. Here and here. Yeah, so this is our graph, and we can move on to part D. Now we need to find the domain and range of our function. So let's part D. Let's start by finding the domain. So the domain is the set of x values at which function is defined. By looking at the graph, we see that x can be any value. So that means that the domain is from negative infinity to positive infinity. We can write it down as d is equal to negative infinity, positive infinity. Well, and regarding the range are those values of y which function can reach. So r is equal to, again, let's look at the graph. If we look at the graph, we can see that the values of y start at 2 and then go up. So our function cannot be equal to the number which is smaller than 2. That means that the range will go from 2, including it, until positive infinity.